Good evening, everybody. We have what we call a modular arithmetic question today, and we're actually summing up 20 numbers. And you can see for I equals 1, it's a fairly small number. That would, let me just write over here, I equals 1 would correspond to 4 plus 5 plus 7, what is that, 16? Which is actually congruent to 0. So if it was just that, it would be not much of a problem, right? That's congruent to 0 mod 8 because 16 is divisible by 8, okay? But let's check out what it would be for the highest one, I equals 20. By the way, this notation means to sum them all up, okay? So there's 20 numbers, and theoretically, I guess, impractically, you could try to sum them all up and reduce them mod 8. But I'm going to show you a better way to do it. That would give us 20 squared is 400, so this would be 1600. Alrighty, which that part's are automatically 0 because it's certainly divisible by 8. But then you would have 5 times 20, which it's plus 100, plus 107. So really, this one would be relatively easy. We got lucky since that is 0 mod 8. But you would still have to reduce this. You'd have to divide 107 by 8. And so anyway, what I'm trying to get at is you would have 20 of these operations to do. You would do a calculation. You have to reduce it modulo 8. And again, modulo 8 just means what is the remainder upon division by 8. And of course, that's going to leave a number between 0 and 7 inclusive. This is sometimes called remainder arithmetic. Okay, I've done a lot of the work for you. Now, there's a nice idea here that I want to show you. At least the approach I thought was best on this one was to split this apart into something that's a little more palatable. And what I mean by that is see if you can look at an expression, a variable expression, and show what it's congruent to modulo 8. Well, if you take a look at these first two terms, you can factor a 4. I'm just looking at these first two terms here. Okay, you can certainly factor a 4i out. And so if you factor 4i out, you get 4i times I plus 1, right? But this all by itself has to be congruent to 0. Okay, when I say congruent to 0, I mean congruent to 0 mod 8. I'm not going to write that down just to save time. Why is that? Well, you already have 4 explicit, and then one of these numbers has to be even. If I is even done, if I is not even, then I plus 1 is even done, right? Okay, so you see how this entire part just becomes 0, which is exactly what I wrote down here. And also notice, you may wonder, well, where did the negative 2 come from? Well, 6 is congruent to negative 2 mod 8 in a trivial sort of way. And they're just 8 apart on the number line, right? These two integers are a distance of 8 on the number line. All right, and so we get down to this position right here, 1 minus 2, and you got, this looks a lot easier, right? Now what we can do here is just note that this would be that you're summing up 1, 2, 3, 4, 5. So this would be equal to, and I'm going to put down equals because there won't be any calculation going on. This would be equal to, I'll just write down the steps here. Remember, y'all, there's a result that says you increment this number and multiply it. So in other words, you have 20 times 21. This is these are the so-called triangular numbers, and they're called that for good reason. I didn't mean to be pretentious there, but that's what the sum of the first 20 integers would be, this number right here, okay? 20 times 21 divided by 2, and that's not actually that hard to prove, okay? Now, right here, you would also have a minus, you got negative 1 happening 20 times, right? So that's minus 20, okay? So you see, you could try to do some fancy out. Let's see, what can we do here? We could factor 20 out, right? Okay, so, and notice, y'all, this is just equality right here. There's no, I didn't do any reduction modulo 8 at this point. Okay, let's factor 20 out and see how this works out. If you factor 20 out of this, you get, and y'all, what I'm going to do here, if you factor 20 out, you get 21 over 2. Minus 1. Okay, I don't know if that was the best way to do this or not, but we'll get there. So this would be the same thing as 20 times 2 over 2, 20 times 19 over 2, right? And so this is equal to 190. Okay, y'all. And this is actually congruent to 6. I should have put an equal sign right there, but this is congruent to 6 because, let's see here, 190 is, if you divide 8 into 190, you get 8, what is that, 20? You get 8 times 20. 8 times 20 is 160. What do we need? 32, 192. 8 times 23, right? Is that 8 times 23 is 184, right? So you get 8 times 23 plus 6. And y'all check my arithmetic on that. Let's see. 8 times 20 is 160. 160, oops. 8 times 20 is 160. So let's see, this isn't right. 8 times 25 is 200. No, 8 times 23 would be 160. No, this is right. 8 times 23 is 160 plus 24, which is 184 plus 6, right? Which gives you the 90, all right? So this is our answer. And again, that's mod 12. It's mod 12, or mod 8 is the, yeah, mod 8, excuse me. All right, so anyway, 6 is the answer I got, folks. And again, this problem was doable, but the way your teacher wouldn't like, or you wouldn't have time on the test, is to do each of the summands. There's 20 summands, and you could reduce each of them modulo 8 and then sum everything up, or there's all kinds of ways to do it. But the big cool idea was this piece right here. Okay. And another way of saying this, folks, is any odd number squared is congruent to 1 modulo 8. That's essentially what this is, the way the proof of this goes. You have 1, but anyway, you can verify that yourselves. So so the answer is this is equal to 6. Okay, good night.